Combo classroom where it's quite cold out tonight here, but I wanted to do a little live video to show some cool ideas that I was starting to discover and wanted to experiment with further here related to graphing cool shapes. A hobby that sometimes I have and sometimes share with this channel as well, because using simple online graphing calculators, for example, Desmos here, we can create using some equations that we will fiddle around with and sculpt to our need and test different variations of and so on. We can create some really cool, crazy landscapes. We may see things that look like personified animals or plants or eyes or flames. May see things that look like little universes. Or maybe we will also just see some cool polygonal or spirally or curvy shapes, like here. We have a mix of some curvy things and some spiky things. And why is that? Well, here, the graph showing, well, there's actually two showing that are very similar. They're the same with one thing different, one element of them. That's one of them, and this is the other that I had overlaid. And these are playing around with a mix of functions from trigonometry, like often make cool graphs, and the least common multiple or greatest common denominator of something, which normally we don't think of being applied to these in-between whole number values. And when it encounters something that's not a whole number, it's going to have to do something like round it to give us our answer. And so you might think it would be a boring graph if we are just rounding different parts to find an integer type function, the greatest common denominator, which normally we could say, like, what is the, well, let's look at some simpler examples. If we were just using this how you often would, what's the greatest common denominator of 6 and 24? It's 6. How about what's the greatest common denominator of let's see, 21 and 36. It's 3. It's the largest number that can divide both of them. How about least, and here we can see they write it in Desmos as GCD of two numbers. What about least common multiple? What that's going to be is, well, no, the greatest common denominator, I might have said this flipped, is the largest number. I hope I said that right. That can divide both of them, whereas here it's the smallest number that can be divided by either of them. And so the least common multiple and greatest common denominator are fun traits in number theory and show up in a lot of different traits of integers. But on graphs, what goes on when we say, like, least common multiple of x and y is greater than or equal to y? Well, that's this graph now. And we're like, whoa, that's pretty interesting. And when I saw this, I was like, okay, I definitely need to put this in a live stream. What wacky behavior is causing these patterns already from the equation? I guess it's buried here. The least common multiple of x and y being greater than or equal to y. And so look at these wacky patterns. We can see lines of rectangles flying off at different angles. This one looks like it's at an angle of a slope of just 1. This one here is a slope of 2, slope of 3. So there's sort of one that is like y equals x would pass through that one, y equals 2x would pass through that one, and so on. Now, that's cool, and also greatest, and let's flip it before we move on. That's the other way, seeing the other part of it. What about the greatest common denominator of this? Greatest common denominator of x and y less than or equal to y also has interesting rays shooting out. You see these things like flying out at different angles. This time we have like y equals x over 2, y equals x over 3 would seem to pass through these. Now, that's just the beginning, because when I saw this, I was like, okay, we can make this really wacky. We can mix this with things like trigonometry to create some cool shapes. And here are a few of the experiments I started with so far. Here we have a slider for A, and you may be like, that's weird, why is it just going from -1 to 1 with a really precise rate in that small range? But that was the range that was interesting for these. We can change A to have a larger range with less precision within how detailed it can be in that range if we need to, but I already tried these. This one is sine of the greatest common denominator of x and y is less than or equal to a. First, let's just see what happens when I make it less than or equal to y. Not that crazy. But how about a? Here at 1, it looks all blotted out. But as I go backward, it like deletes these squares in an interesting pattern. You know, look. And it's like, what is the pattern that makes some squares disappear at this step? What's going on there? Desmos probably is not doing it perfectly because they say it contains fine detail that hasn't been fully resolved. However, often if they're making a mistake, it's a sensible type of mistake that does relate to a pattern. What pattern is going on here? We can see these different phases, and if you zoom out a little bit, we can see, like here, we get a 3 in a row at some spots. And it's a strange web of this shape that grows. So now there's that, and here's the same thing, but with least common multiple. This one's even cooler. Look at this. It looks like a cellular automata that's building up and down or something. Isn't that trippy and cool? Okay, that is wild. Now, that's still just the tip of the iceberg because I knew we could take it further. And another, I'll delete these because we'll be making new experiments as well. We don't need A for a minute. Here I have the greatest common, this one I showed. Here I tried, what if we put a tangent over it? Well, I tried others too, but tangent was extra cool. And I played around and found that a cool one is greater than or equal to the tangent of x times y. That's what this creates. Okay, at this scale, it has a lot of detail lost. It has a lot of glitches right here. In fact, I think I see this guy called Bernard. That's a classic Desmos glitch that has been nicknamed by the Desmosers. Yeah, that's Bernard right there. But now let's zoom in a bit. And we can see this. Now, I want to compare it to something. I want to compare it to if we had something here that instead of greatest common denominator of x and y was just like x or just like y or something. This is already a cool one. This looks sort of jungle-like with these fronds coming out. And we get these curves. And sometimes when we do stuff like this, we get these sort of spirally things. But when I put the greatest common denominator, it has this really interesting mix of curvy and spiky. Isn't that neat? It has this weird pattern, and you can zoom out and see a different scale of pattern. Look at that. Look at this other pattern that's like that thing we saw before. Let's flip it too. And I will be checking the chat in a minute, so feel free to leave any questions or comments in the chat. For now, I just wanted to jump right in, but I will be checking that here and there. it's a little clearer this way. I kind of like it like this. And it's kind of cool because when we're close, you wouldn't necessarily tell that these are trying to hint at a square. It's like, okay, a little bit and a little bit. But those are hinting at a square, we can see. It's like squares with bits cut out of them. And the squares form a strange pattern. So, we're already in Wildland. Let's next try least common multiple, which is similar. Often, least common multiple and greatest common denominator will look similar. Sometimes we'll overlay them. Like here's the same color overlaid with greatest common denominator and least common multiple. So where it's darker, it's fitting both equations. Where it's lighter, it's fitting one of the equations. Where it's white, it's not fitting any. And when it's a filled in line, like a darker line, that's where one of the equations meets equality as opposed to just inequality holding. So those are pretty wacky. Let's save those to edit in a minute. The one other experiment I had here is I wanted to put the least common multiple and greatest common denominator against each other on different sides. And for example, I tried, what about sine of the least common multiple of x? Well, first let's just try the simple one. The simple one would just be least common multiple of x and y is less than or equal to greatest common denominator of x and y. Boring. But when we put the signs around them, we get something more interesting. We get this pattern. That is pretty cool. It's hard to predict what it's going to do. It has such weird patterns, seemingly. There's got to be a method to the madness, but from a quick glance, I don't know what it is. Looks sort of like a video game from the 80s of like some space invaders flying in or something. Now, here is similar but with cosecant as opposed to sine. Now, that one looked kind of cool too. Now, we're going to jump in with adding some new ones. If anyone wants to play along at home, let me know either in the live chat or in the future comments when this is more like video form. Because the live streams typically stay on the live tab. Let me know if you find any cool ones related to this that you think would be fun for me to click on. And Wade is wondering, if it evaluates the least common multiple of non-integers, does it just apply the floor function, or does it round up and down based on what side of 0.5 it's on? I believe it rounds. I'm not positive. If anyone has more details about the inner workings of this graphing calculator, let me know. I'm assuming it rounds, but I'm not positive. And we also have a comment that it's reminiscent of Pascal's triangle and or Amenger's sponge, however you pronounce that. And yeah, it is. And we will be doing more episodes about fractally shapes in the future. And thank you just for the people who are leaving nice comments. Anyways, trying to now see which ways we can distort this and make it a little crazier. One of the first things I often like to do is put in a few variables that we're going to have an A, a B, and a C. And let's just see if any of these make it significantly more interesting or what they do to it. Sort of interesting. Switching it up a bit. Whoa, that flipped it. Look, something flipped right here. Yeah, what happens when they're all 0? That's just going to make it really boring, probably, yeah. But what about if these are random things and that one's 0? Now it's interesting. Now if I play around with this, it's like different square patterns like we were seeing before. Here, let's put these both back to 1 and just mess with A over there. That was B and C, but look at A. That's crazy. Look at like a rectangle of squares here and how it gets sort of warped as this thing passes by it. By the way, I jumped right into the episode from the beginning, But I should mention, if anyone didn't catch it, there is a new main combo class episode on my main combo class channel about paradoxes. So that's linked in the description. Make sure, if you haven't seen that, to catch that after the stream. Sorry I still haven't jumped back into posting a bunch of shorts on this channel. That is a goal I have in the near future, to get back into that. But the main channel has been having some pretty frequent episodes, so make sure to catch up to the grade -3 bits you've missed sometime. And here we can see this pattern that repeats a lot, where we're zoomed out. It reminds me of a lot of different sorts of diagrams I've seen, where, like, if you took a grid and you're like, this is 1 through 10, this is 1 through 10, and we're filling in the ones where, like, the product of the numbers has some trait or something like that. And it's hard to predict exactly what pattern is going on here. You also can't even see, at a still state like this, exactly where the squares are or aren't. But when you move this through it, you get a clearer view of where, especially when you're here. This is like what's actually in there. But we can see a clearer view of that when this is sliding compared to when this is at a single state. Now, and we have, someone notes, how would it look like with factorials? That could be a fun thing to add. So why don't we try that? What we're going to do with these is we're going to have A, B, and C set to do nothing, but ready to go. And when we set them to do nothing, they're either going to be set to 1 if they're multiplying by something, or set to 0 if they're adding to something. Like, we could, for fun, say plus D, you know? And D would have to be set to 0, though, to not have an effect, because that's additive. And so here we have a few ones of these, and what we're going to try is, like someone said, a slightly simpler one, but then with a factorial. What happens when I take the least common multiple of x and y, factorial, being greater than or equal to, let's just say y for now. And it makes this strange shape. Whoa, what is that hinting at? That's interesting. Now, to note, factorials, like least common multiples and greatest common denominators, typically are just used on integers. And so here they're extending it with what's called the gamma function, or perhaps an offset version of the gamma function. I will make an episode about that someday, but for now, just note that there is a sensible extension to factorials that they're following to be able to fill in what the non-whole number ones should be. Now, let's now try what happens if I had some factorials in it. Whoa, that like didn't change it much, but it left some glitches there or something. Now the glitches sparkled away. What about, ooh, whoa, now we're to another strange one of these mystical patterns, where this one, I've now sort of deduced from looking at it that these lines sort of line up with like a slope of 1, a slope of 2, and etc. And someone said one looked like a key, and yeah, some of them did look like keys. And I love how humans have the ability to personify things, or to just humanize things, to say, that looks like a so-and-so. We evolved that for a reason. When you were in the woods, you wanted to be able to look through some trees and be like, whoa, that looks kind of like a face back there. And so now we can apply it in all sorts of weird creative ways by being like, I'm going to play around with graphs, and I'm going to pass by something that I'm going to think looks like a key. Someone else thought one looked like an airplane. Yep. And the extra cool thing is someone who reads those comments after and doesn't know what part you are commenting about will then be wondering, okay, which bit looked like an airplane? And they might even see airplanes in places you didn't, or see keys in places you hadn't thought of. Because I like leaving it vague. At first I was going to be like, we should say when you saw that so people know, but maybe we shouldn't. Maybe we should leave it so they have to wonder which one looked like an airplane. Now here we can see it gets smushed a bit. These get flattened in a sort of way. And we have these things. So, whoop, I went to the background. Uh-oh, go back. Okay, there. And that's pretty neat. So now, factorials did something cool there. Let's try one or two more experiments. They're going everywhere. Okay, now this is strange. What pattern's going on there? So factorials we may throw in here or there. There are other sorts of things we could try too. Like, we could do modular arithmetic. What if we say, like, the least common multiple... Is it going to let me do this? Of x and y mod y is greater than x? Yeah. So let's do greater than or equal. So I don't like the dashed lines as much. They trick us because sometimes it actually does look dashed on these graphs. Okay, so those are cool. These look like a weird, like a key, but like if you were a burglar, like a tool you would use to get into a lock. Like the unofficial key. Or the longer ones now look sort of like a spear of some sort. These bumps have interesting patterns. This one's like way flatter than the ones on either side of it. So that's... oh, here's another flat one. I wonder when the flat ones hit. Not fully flat, but flatter. And that goes on that side. And for fun, we'll throw in a factorial. Yep. Okay, now taking that away. Will it go too crazy if I try the least common multiple of x and y in mod the greatest common denominator of x and y? Oh, that one's boring. Okay. Also, for now, when we're saying greater than or equal to something, instead of just x, I sometimes like to default to x times y as the opposite of some crazier side. That just tends to add more coolness, but we can try different variations. X plus y would do a different thing. So now we're going to take away the mod and the factorial for a minute, but we're going to try including more different varieties of the trig functions. And what about square roots or something like that? We haven't tried any of those fellas yet. So what if we try the square root of... Let's try this without any trig functions first. Of the least common multiple of x and y is less than or equal to... already this one's kind of cool. It has these little miniature things, and then the rest of it's a void. And we're going to say square root of the greatest common denominator of x and y. Oh, that's kind of neat. It's not like that detailed, but it's kind of cool. Okay, and Wade in the comments has a suggestion for one that's kind of cool. Just one day, I know it's going to happen someday that someone's going to be so clever and come up with an equation that looks like something inappropriate and get me to type it in and try it, and something inappropriate will come on the stream. But since you would have to learn a lot of math and a lot of creativity would be required to figure that out, I'll let you try. But for now, I think this is just going to be a cool looking graph. Greater than, I'm going to assume greater than or equal to works y. Oh, that one is cool. So below the C, we have only filled in. Here we have like almost all filled in with a little air bubble. And then here, that goes up in a strange way. These ones spike off like that. These ones spike off in a strange way. All right. Now, what about if we had made it x minus y? Flip some things. What about if we had made this x to the power of y? Oops. Yeah, well, what happened when it was negative y? Okay, less interesting. Okay, so that's pretty cool. Let's try a little combo of a square root and a trig function. Square root of sine of the least common multiple of x and y. And first we're going to do a simpler one, which is greater than or equal to y. And, oh, I was going to say boring, because above it's boring. But look down here. Not boring, this whole tunnel system. A type of mole dug this very rare tunnel system. Which, these patterns, someone please comment if you figure it out, any of you. What sort of pattern determines what this looks like? I mean, we sort of know what pattern. We know the equation of it, in fact. We know a very detailed, precise version of the pattern. But, like, why? Why does this equation result in, intuitively? Why is this bit filled in and not that? I'm going to put together at some point. There will be an episode on the main combo class channel of some of the graphs where I have figured out why they do the weird stuff. I'll collect some of those because some I figure out after the fact. Like, I'm not going to sit down for an hour now and just see if I'm able to figure out what this is doing. But some I have figured out after the fact. I will collect those for videos sometime and return to some of the best, greatest hits of the previous graphs. Now, let's now try something similar on this side, but with the greatest common denominator. Okay, there's another interesting-ish pattern. And these really look like cellular automata. And if you don't know what that is, don't worry, someday I will make an episode about those. But they're similar to like Conway's Game of Life and other things with a similar type of pattern. Now, what I want to try here is a few other trig functions, tan, and see what we can get from the other ones. These are pretty minimal. Now, as some people who have seen a bunch of these, ooh, that one's good. I like that. So here we have like a circle. Look at this circle. Yeah. Do we get more circles? Sort of. It's like a glitchier circle. The circles get more glitchy until at some point you can't tell they're circles. Still kind of circular. But, whoa. Often when you zoom out, you see patterns like this that are like just Desmos tripping. But it's not just tripping there. That is a circle or circular thing. I mean, I don't know if there's any tripping occurring in the inner workings of how precise this is. But as I mentioned, if they're getting something wrong, there's still some reason it looks like this. And regardless of whether I ever figure out why this one is doing this thing or which ones I do or don't, I just think it's awesome that you can like create paintings just from playing around with equations. So also shout out to Desmos, which is the website we're doing this on. And here we have, it's not sponsored by them or anything, but they're a good tool. So that was with cosecant, and I often use cosecant, tangent, and sine as three representatives of trig functions because they have sort of different cool effects. Like trying cosine often is similar to sine. There are some others that look similar to cosecant, but these are sometimes different families. And let's see if only one side had a square root. I like how it squarifies things. It like makes almost any graph have some form, you can see. Even if it's like a blocky-ish form. And sometimes you get shapes like this, like these two tetrominoes touching, that make me wonder, like, do those occur again later? Do things get... Because here we have like pretty big clumps. Like, look at that thing that just emerged all the way out here. And here, yeah, there's a good old hexamino. So yeah, dude, the cluster... Whoa, look at this all the way out there. Look at that all the way out in the void. This is so crazy. I feel like I'm hiking. I feel like I'm like going through the wilderness and I'm like, ooh, look at that cool rock. So, like, what comes next? It is very hard to predict. And whoa, look at this bit. This looks like an ant or something. This looks like a big bug. Look, its legs, its body, its head, its pinchers. And I was wondering if the clumps get bigger or smaller. Like, are they going to dissipate to not as clumpy, or are they going to have bigger clumps going out? And look at this, like, line part. This, like, bit just goes up pretty intensely right here. Why is that, like, this whole sector? You would not expect that all the way out there. I have no idea what you would find in different corners here. That is wacky. And I want to zoom out, but you can't really see at a certain scale what's going on. Uh-oh, I've lost where I am. I'm lost in the wilderness. Always bring a map. Okay. Oh, speaking of which, I actually went to my friend's cabin a few days ago for a couple days, or for like 4 days, and that was cool. Part of the last episode was filmed there, and there's other footage I have there as well. And it was just fun. Got to visit the snow. Got to get spooked by a pack of coyotes one night. I didn't actually see them, but they sounded like there was a lot of them and that they were very close. And we had to walk through the direction where they had been howling. Like, they were howling, and we're like, oh, what do we do? And we waited a minute, and because they sounded really close. And like, there was a bunch of them. And then we were like, it's just getting darker. They stopped yapping, but we can't just wait here. So we had to walk through that direction, but we didn't end up seeing them. And we have some good notes from Wade. Not going to fully read that all, but interesting thoughts for people to ponder in the comments. We have some other cool comments from people as well. Someone saw an upside down tree. Oh, whoa, is this a square-like thing? Whoa! You know how we had a circle before? We have like a very square. It's almost a square. It's technically sort of squircle-ish, but no, it's a square with missing corners, we can call it. Square with missing corners. Look at that square! Who knew? Until I zoomed out. Whoa. Okay. I'll leave that up to edit in a second. We do have another suggestion in the comments, so let's try the suggestion. Greatest common denominator of a times sine x and a times sine y being greater than or equal to, I'm assuming greater or equal works, 1. And vary a with a slider. Okay, so a is at 1 right now. Whoa! Yeah, so here we have like a lot of a grid-like thing filled in, but not quite all squares. Some do appear to be. Ah, yes, we get square. Whoa! They glitched in. And oh my god, I hate when it's so muddy out here. My chair sinks so deep. Like, I wish I could show you the angle, but it's too dark to see. But at least half of the height of the chair is sunk into the mud. And when I sit on it, it goes right back in because this chair, all the chairs I have here are too pointy. Okay, anyway, that's a me problem. Whoa, it glitched in again. Is it going to keep glitching in? Okay, this is a really cool one. Thank you, Wade, for this one. Whoa. That is crazy. And it's a pretty simple equation. It's like a fractal it's forming. Okay, I need to make A have a bigger range. Whoa. Oh. Well, everything glitched together, maybe. Okay. It looks like forming a fractal almost. But it has different intermediate phases, like a pulsating fractal. Whoa, this is crazy. Okay, I gotta edit this one a bit, because this one's awesome. And it's so simple. This is, according to Desmos, when the equation, like, let's pick a simple number for it. Like, this particular one is when the greatest common denominator of 20 sine x and 20 sine y is greater than or equal to 1. So now let's make this slider equal to b instead of 1. That'll be our first edit. And what happens at, whoa, it like lost, whoa, it's making some of the details get lost, but it has a cool pattern. Look at that. This one looks 3D. It's like an optical illusion. Leave a comment if you see this going in or out, because I can sort of glitch between seeing it as like a spike going toward me, but more so it looks like it's going in. And that's pretty cool. Let's get b back to 1 for a moment, though, and edit something else, which is we're going to have one of these be a different variable. And c is 1 and a is 20 there. So they're too far apart. Get them back closer together. A and c are both 1 now. And why did it all go away? Why did it all go away? What happened? What did I do wrong? A and c are 1. What went wrong? Is it using the right c or something? Oh, it's because... What happened? How did I lose what it was supposed to be? Okay, now it's back, but I guess I had these just timed at the wrong combos of them or something. You can have a wrong combo too, trust me. I would know better than anyone about wrong combos. Sometimes you have to encounter wrong combos to figure out how to cook the best right combos. But this sentence is wrong, so what do I know? Now, let's see. That's a cool one. Now, I wanted to edit this, and for some reason, I lost it all. So, A right now is -40. If I set C... Oh, C's range was different than A's. That's probably part of what was throwing me off. So, if I make C -40 and switch A with C, it'll stay the same. And can I just offset them a little? Yeah, this is what I was trying to do. Have it glitch in some way. But, let's see. If you got to move them together enough for it to glitch to a new state, I guess. Yeah, that's pretty neat, but it was almost fine having those there. Let's now instead try throwing C in one of these. Whoa, that got maybe too crazy. Where's the origin? Okay. So, C will get smaller. Okay, yeah, C does some strange crunching and combining. So, C there messed up a little too much. And let's see what happens if I put like an X or Y on that side instead. Ooh. And we're going to do AX, and then we can still edit that. Put A back to 1. Oh, that's boring but interesting. And here we have editing A. We got that. Oh, it's reminiscent of a sideways version of the thing we saw a lot earlier. Let's make it a different variable, though. C. Whoa. That's cool. If you just saw this, you'd be like, that graph's boring. But what about when it does this? Is it boring anymore? Whoa, so this is cool. It has a weird pattern. Oh, no, it's doing a similar thing. It's just smushed. Yeah, this is when it does the rays, like a line that way, a line this way. But a cool thing I'm noticing now is it does this every one, the one that has a slope sort of like 1, or -1 in this case. And it does this like, does it do it every other one? No, just combined on that one because they were close. Yeah, I guess that is a distinct square. They're smushed together. We have a comment about how similar to how 123 is 120 plus 2 point, I don't know if you mean infinite nines. If you do, then yes, that's exactly correct. But even if you just mean a bunch of nines, a calculator would get tricked in that way. And that's the second most recent main combo class episode, calculator errors. And so make sure you've checked that one out as well. Oh, this is cool. So this is like here's what I'm going to envision it as, although it's sideways. Imagine it was tilted the other way, or you're an alien who has gravity that goes left. And here, that line's the water. And look what happens when the water starts going up. The people have to rebuild. Build higher, higher. The water is coming. Up here. Oh, did the water eat all? No, the water didn't eat all of it. It's still up here. Will the water ever eat all of it? Maybe the water ate all of it. It's hard to tell. Oh, but over here, the water all drained out of there and left a nice beach behind over here. Ooh, that's a cool state. This is like in between the water going the other way. It leached out to have enough of this effect. That's pretty cool. These also look sort of 3D. Okay, now this was one of the extra crazy ones, was editing A on this. So let's try and edit this just a little bit more. And first I need to just find the origin. No, it's this way. Here. I think this is the origin around here. Yeah. It's all pointing to the origin. How did I miss it? Everything's like here. Okay. Let's try a few random experiments. The first is going to be putting a square root on one of these parts. And remember, we can change A. Oh, whoa, it like mushed some stuff. That's pretty cool. They're now in just these little slices. They do their thing. It's like in these tall tubes. Wade said that to me it's not as pleasing when it gets too crazy, and that it's good to have a balance of order and unpredictability. I can agree with that sometimes. Maybe I'm jumping through it a little fast, but I'm kind of jumping through it really fast, not as much because that's how it looks cool to me, and more because that's a quick way to find the coolest ones to freeze on. But the ones that are a bit ordered can be neat. And square root was all right, but let's try some other things. What if this was XY? Ooh, that one's pretty neat. And remember, we haven't even edited A yet. Whoa, this looks like Dr. Seuss-like or something. Whoa, look at these like tilted. This looks 3D. Whoa. Whoa. Okay, now let's edit our A. Oh, no, wait. Our A was edited. It was equal to 40-something. What happens when A is 1? Nothing. It's gone this time when A is 1. What about 0? Gone. You have to be more than 1. And it gets through some pretty wild states. This one's too crazy. How about like 5? Ooh, yeah, that's pretty wild. Actually, maybe like 10. Yeah, that's what I'm talking about. Whoa. All right. So that was putting an XY there. What about X plus Y here? Well, that made something interesting. That's neat. And then let's get it to its simplest state. Can we get these more precise? What about -10 to 10 with a smaller step? Can we go in between steps for a good effect? Yeah, we get more in-betweens here. Now, I think negatives are doing something similar to positives, so let's just go 0 to 30 instead. And does it still let me do points? Yeah. Okay. So, now, these were some cool experiments for that. To try one last edit, let's put a variable here on that side. Oop, it all went away. Did it? Oh, that's a state that it passes by, and maybe we need our A different to make C have more options. Oh, that's a good one. That's pretty neat. Okay, now what we're going to try is we're going away from this one. Feel free, people, to try your own experiments and let me know if you find any good variations. For now, we're going to simplify things a bit, but what I want to try is having a few things that we're going to edit in conjunction. So we're going to try the sign of the greatest common denominator of x and y. We'll say that we're going to say the square root of all that is greater than something. And do we get anything there? Ooh, sort of. Maybe not quite. Maybe the square root was due. Oh, we do get something there. But that's a good starting point. We're going to try one there, and we're going to simultaneously try least common multiple. And let's, oh yeah, because see, they overlay in a cool looking way. Let's make one of them blue and one red. And, you know, when it's purpley, that's when both are happening. So actually this that looks like red here is both. And this is when it's only red, that little spot. And so that's pretty cool. And when we change A, we'll see that they change together. Okay, now instead of that, let's remove our square roots and put some more stuff on the other side. And what we're going to try is another thing involving the same type. And then, well, here's what we'll do. We'll do a big combo. We're going to do same type with something slightly different. So here we're going to have to say, like, the greatest common denominator of x and xy or something. Does that, what went wrong there? Cannot access coordinate point x of a number. Yeah, I didn't mean point x. You're right. I meant comma. So, if we had this as a starting example, there are sort of 4 clones we can make of this. This one was greatest common denominator, greatest common denominator. I mean, 8 clones if we flip the inequalities, but not counting that. We could do one that is greatest common denominator compared to least common multiple. And I guess if we, maybe there's less if we don't count the inequality flips, because I was going to then do least common multiple compared to greatest common denominator, but that would be the flipped, or not quite the flipped version because of that. It is different because I have an edit on one side. So then we have that compared to that. And then we have least common multiple compared to itself. And now when I edit one of them, I'm going to go to each of these and do a quick edit to each so that we can see this whole family of 4 friends. And we're going to make them different colors. And what? Okay. No, change the color. What color will be most visible? I don't know. That or something? It's going to be hard to make it fully visible with 4, but it looks cool. We can see a weird square there. We can see all sorts of weird spiky, round things. And we're also looking for the darkest spots are interesting because that's where most of these are filled at once. Now, let's say we're going to change one of these on each to a cosecant. And we're going to, does that destroy everything of the interestingness? Not quite. There's some interesting stuff, but some of the stuff is only happening like fully together or something, or some of them happening everywhere. That one's happening almost everywhere. almost everywhere. And then that one just looks less interesting because some are happening almost everywhere. But we're going to try when they're both cosecant. Okay. And, uh-oh, I zoomed into the page, not the thing. How do I even get out of this? I'm zoomed into the page, and so if I try and zoom out, it's zooming out of the graph, but it's zoomed into the page. How do I fix that? The whole screen is zoomed into the page. What? Am I gonna have to like restart or something? Someone who's watching live, help. What do I do to make it? I guess I can try and change the size of it like this. What? No, what's going on? It says it's 100 right now, but it's zoomed in. I can't see the thing. Someone said Control Plus, and that's what I just tried. That's weird it didn't work. Maybe I glitched it by doing too much crazy stuff on it. But I think we got to reload it. Okay, we're going to be starting from scratch real quick, but that's okay. We don't need 4 right now. That was neat for a minute. We're going to try 2 right now. And what we're going to try is one where we have something with the greatest common denominator of x and y. And then we're going to have something slightly different, maybe just a different, thing of a trig function for the least common multiple, and then we're going to flip them. So a family of 2 will be enough for now. There's that, and here's where they're flipped. I guess we might as well make 4, because it's the same thing as before, where if they're different on different sides, we have a bunch of options. So we're making 4. And purple is going to look like red plus blue. Maybe orange is a little better. So that's where we're at right there with that pattern. And instead of having this be a different trig function, let's try putting these back to sine. But we're going to put a multiplier onto some of these. So now we can sort of move, and different colors as we move to different parts of this. We'll get their different times to shine. So that's all pretty wild. And let's see. Now, let's go back to, and let's remove the trig function from one of these to simplify things. And, oh, that's boring. And then, oh, we simplified it way too much. Okay, there's one interesting state here, but what we're going to try is put something else interesting, like the square root. Doesn't do that much. Maybe that didn't work. Maybe we needed the trig function. That's when one is tangent might be wacky, because tangent can do some pretty crazy stuff. All right. Now, to try some comparisons of some things I'm curious about, let's try combining it with the rounding floor or ceiling functions. That's going to like double round it sometimes, or not exactly twice in a row, but like what happens when I take the least common multiple of rounded x and floor of y? It's greater than or equal to y. Oh, that was kind of cool. It made one of these. I'm surprised it actually worked and did something neat. What if they're both rounded? Okay. What if they're both the floor? Okay. All right, so that actually did somewhat work. And what if we had rounded this one? Okay. Now, what's going to happen if we try and iterate it a few layers deep? Greatest common denominator of x and y and greatest common denominator of x plus y and x times y. And that's greater than or equal to y for now. So that's not that crazy, or xy. No, not that crazy there. That one didn't work. Oh, to 1 almost worked better. Yeah, we'll have a constant. Oh, it's got to be good. Oh, there. We saw a little shimmer of light. There. Look at this. This graph is hinting, I can be more. Push the A higher. And then for a second you lose faith. But then it does do more. These are kind of neat. And these have more like circular things, it looks sort of like, in their like shape. You can't tell from up close, but like the places they're cut around seem circular, unless that's just Desmos doing its weird zoomed out look. So this one didn't work that well, x plus y, x times y. What happens if we try ax and y? And we move around a bit. Ooh, that was a good state for a minute. What was that one for a moment? There, that one's neat. These remind me of mazes. I used to sometimes draw mazes on graph paper. So you'd draw around different lines and edges on the graph paper, and it was a fun type of maze to design. And this reminds me of that. And like going around, traveling through a path, trying to find the right way out. Pretty wild. Okay, let's try and iterate it one more layer deep. So it's going to be kind of crazy, but we're going to say this one is actually the greatest common denominator of x and y, and the greatest common and the least common multiple of x and y. Okay, so that's similar to one we've seen a few times. That didn't actually change that much right there. But what if we switch around a few of these? Does that change anything significant? I don't know. So that wasn't changing that much. We need to change more of these. Like, what about if it's x, y there? Or, oh, this isn't even changing that much. Well, it's hard to change that one. That one was like bulletproof for a minute. This is kind of neat. This is one of the ones where like up close you wouldn't really know what's going on, but zoomed out you don't really know what's going on, but you can see some curves and different shapes. This looks like almost like wrapping paper right here. Someone noted, Al Dub said it's stained glass math. It does look sort of like cool stained glass patterns. And if anyone does have any thoughts they'd like to share, I probably will wrap up the live stream before too long. So leave any last thoughts that you have now while I show a few last experiments. And this one's kind of cool. These look like a particular like tool or something. Oh yeah, it does. Look. Oh my god, it's a spatula. Look at this. Tell me that's not a spatula. Look, that is the top part of the spatula. That, it has little spikes on it for some reason. That's the handle. That is such a spatula. There was one time a while ago, I should go back and see which graphs this was, where it looked like, I swear, a burger factory. And that sounds absurd. Like, what do you mean the graph looked like a burger factory? But once in the graph, it actually looked exactly like a burger factory. I'm going to revisit that and see which one that was sometime. For now, that was pretty interesting, starting to do weird things here, but these ones were harder to edit. Oh, whoa, when we did a power there, that was weird. Okay, how about a little less iteration, but do try some powers. And we try x to some power, and y to that power. Nah, y doesn't get the power. Is greater than or equal to y to that power. What will this do for different powers? Oh, sort of flickering. Whoa, now does this look... Whoa, that one's... I was going to say it's boring and I didn't like this one, but I like it now. This one's cool. It's an hourglass. Look at this hourglass. Okay. And now let's try if one of these was x. So that's kind of a wacky little curve there. This is a strange graph. And what if instead of that being x, we just had y? Whoa, this one's neat. This was simplifying it, but it's cool. Oh, this is the sandwich the spatula was getting ready. Look, this one looks so much like a sandwich. Sideways, a sideways sandwich. And that's x to the x would do this. What about y's to the x? Ooh, that's kind of cool. And we lost our a. Oop. Whoa, that's kind of cool how this one builds. Ooh, yeah, it paints this interestingly. Like you see it as it comes in, it paints this. Someone asked what program this is in. This is on Desmos, a free online graphing calculator that, just from the experiments I've done so far, is one I like. So you can, I guess it's desmos.com. And the bit I'm on now, I guess, is desmos.com/calculator. But they make it pretty obvious to find this part of it. All right. Although sometimes I swear, Desmos felt to me like it would be a .org. I don't know why. It just felt like it would be a .org. So sometimes I had gone to desmos.org and it would send me to some other website. And then, because I had done it a few times, it kept remembering it. When I would type in just Desmos, enter, it would go to the wrong one, and I had to make it forget it. It did a similar thing with, like, the game Wordle. It turns out Wordle is not Wordle.com. And when you go to Wordle.com, it redirects you to this thing called something hoax. And I was like, what the? Oh my God, what's happening? So it's just, it kept remembering that. So whenever I was like, I'm going to play the Wordle, it would go to this website with hoax in the title that freaked me out. Okay, so anyway, be careful with that. And I'm going to wrap up with a few last experiments while I chat. And while I wrap up, I will remind you folks that, as I said earlier, there's a new episode I put out last night that is about paradoxical sentences. That is linked in the description. And I haven't put that much on this bonus. This is technically my bonus channel. I haven't been as focused on this channel recently, but I am going to jump back into some more shorts like I used to post tons of on this channel. And I have been posting bonus videos here and there, but I'm going to get back to another era of many shorts. So because that's what this channel originated as, was the channel to post shorts on. Because just a couple of years ago when I created it, the shorts were amalgamated into the same tab on a YouTube channel. So if you put shorts out, they would clog up your video feed for your channel. But anyway, I will be putting more time into this channel again going forward. I just wanted to get a few life things in order and get back on track with being more frequent with the main combo class channel, which now I've gotten back to putting out an episode every 1 to 2 weeks. And now that I've gotten back into that groove, I will get back into, and maybe even further than ever, some good bonus stuff on this channel too. There is also some bonus stuff I've been posting on Patreon, like random behind the scenes from my life and stuff. So that's also for YouTube members or Patreon people. They get the unlisted videos of those. So consider supporting those ways if you want any bonus stuff and to help me make my videos. And there's a lot of cool stuff coming this grade. We are, maybe 10% or maybe 15% of, or let me think. We are maybe 20%. I don't know. Yeah, probably 20% of the way through grade -3. And I have a lot more cool things planned this grade. New topics you'll be surprised by, and returns to old cool topics, and a lot more. And I'm going to wrap up very shortly. Thank you all for joining me. And if you like the live streams, remember that almost all of them I save as video-like things after the fact. They stay in existence on the live tab. So you can always watch old live streams if you like them. There are a bajillion of them on this channel. A lot of hours of live stream content if you're ever bored. And a lot of other fun things will be coming soon too. But I believe I will wrap it up there. I hope you folks all enjoyed, and I love you. I will see you again